just like a simple, like, will there be like find like the fifth or sixth derivative or something like that? Is that what you're talking about?
So if you're asked to find a higher order derivative, let's say as an example, I may have x to, I don't know, the sixth plus 2x to the fifth, and let's say I'm asked to find the third derivative. So let's say this is the question. You will find the first derivative first as 6x to the fifth plus 10x to the fourth. You will find the second derivative as 30x to the fourth plus 40x to the third. And you will get to the third derivative either written like this or like this as 120x to the third plus 120x squared.
Okay.
That's all you need to do. And if you're asked the fourth, you're going to differentiate this one more time.
Okay.
So that's about the higher order derivatives. That's the higher order derivatives.
I do have one question.
Yes, I'm ready.
So it's to find the derivative, and the equation is f of x equals parentheses x squared plus 1, parentheses x minus 4 all over x cubed. So the only part where I get tripped up is dividing after simplifying, of course, like each one by x cubed. So I just want to walk through it.
Of course. So one more time, there is no power on these. It's x squared plus 1 quantity multiplied by x minus 4 and everything over x cubed. Am I correct?
Yes.
Perfect. So yes. So this is what I would do. Are we asked to find the first derivative, the second derivative?
It's just the first derivative.
First derivative. Very good. So let's distribute. X cubed minus 4x squared plus x and minus 4 divided by x cubed. Remember I emphasized that property that a plus b over c is the same with a over c plus b over c and vice versa. So I will rewrite it as x cubed over x cubed minus 4x squared over x cubed plus x over x cubed minus 4 over x cubed. This is 1. This is minus 4 over x, which is x to negative 1. When I simplify, I get an x in the denominator, which is 4 times 1 over x. When I simplify, I have plus x to negative 2 because I'll simplify and I'll get x squared. And here there is nothing to simplify, so I'm going to write it like this. Let's go back for a second. These are the same, so it's 1. When I simplify here, I have 4 over x, which I will write like this. When I simplify, I have 1 over x squared, which I will write like this. And here I cannot do anything, so I have to write it like that, as negative 4x to negative 3.
Okay, perfect. Yeah, that makes a lot more sense.
So this is exactly what we did, but because we already did a problem like this, which is fine, I always like to go back to any problem you need. I already divided. So I said this divided by x is this divided by x is this divided by x is this. But I use the same process, basically. So now when I differentiate, this is making my life so much easier than that, the original one. So this is 0. I bring down negative 1, so 4x to negative 2. I bring down negative 2, x to negative 3. I bring down negative 4 plus 12x to negative 4. Is this better?
Yes, it is. Thank you.
Perfect. Anything else that we need help with? Anything?
Say we're solving something like this on the exam, do you want us to put it back
I'm happy with this. No. No. Don't forget to make a page of notes, front and back. Don't forget to make a copy before you take it with you to the testing center, because they will take it. You have to submit it. You have to surrender it. It will be, I will scan it and send it back to you, but you want to keep a better copy than the one I scan and send back to you. I have not, I'm grading tests for 2 other classes, so I did not get the chance to see where you are with Pearson. But please remember, by Monday night, R.1 through R.5 and 1.1 through 1.8, all of them, each and every one of them have to have a minimum of 70%, please, in order to qualify to take the test on Tuesday. Okay, I'm ready. Anything else? Other questions? The definition of the derivative function. Do we need help with that? Do we need help with domain? Equilibrium point?
So we know the definition of the derivative function.
Yes. I was hoping somebody would say that. Yes. So a simple example, let's say f of x equals -3 x plus x squared. You have to start by writing f prime of x. You have to continue writing limit as age approaches 0. You have to write the definition, f of x plus h minus f of x divided by h. Then you have to write limit. Do not drop the limit operator till you apply it, please. Then you have to write this, -3 x -3h. I know what that is, minus x squared minus 2xh minus h squared, plus 3x and minus x squared divided by h. You can make some other calculations on the side if you want, but we've already done this many times. Remember, all terms without h must go away. If some terms with h go away, it's even better. Okay, so then limit. So from the very beginning, what I would do when I'm asked to use the definition of the derivative, I will immediately find the derivative as I know how to find it, and I know where I'm going from the very beginning. Okay, so then I have limit as h approaches 0. I see 3 terms that have h in common. H is out, -3 minus 2x minus h divided by h. And when h is 0, oh yes. Okay, so -3x minus 3h plus x squared plus 2xh plus h squared, and then plus 3x minus, okay. So these two go away, these two go away. Perfect. So -3, 2x plus h. This is gone. When h approaches 0, I get -3 plus 2x, exactly as I expected.
Oh, so you're just like fact checking if the derivative.
I will immediately do that, so I know exactly where I'm going.
Okay.
Even the problem says you can check after you finish or before you finish, you can check with the differentiation rules. Even if you don't write it, if you don't want to write it, you can, just know where you're going.
Okay.
This should not take long. Perfect. Anything else? Anything else? Other topics, other questions, anything else you need help with?
Can we go over the main
Yes,
domain?
yes, of course. So one typical situation would be, let's say f of x equals x plus 1 divided by 2x minus 1. What will you say about the domain of this function? What do I have to write?
2x minus 1 can't equal 0.
Excellent. So x cannot equal 1/2. And then you will write the domain, negative infinity 1/2, union 1/2 infinity.
Okay.
What if we have a square root function? Let's say we have f of x equals the square root of 2x minus 1. What would you write in this case?
Minus 1 can equal 0.
The square root of 0 is 0.
Is it less than or equal to?
That would be a problem because the square root of a negative number is not real.
Is it greater than or equal to?
Indeed. So x greater than or equal to 1/2, so then the domain will be 1/2 to infinity, always. Now, if this fraction, if this is in a fraction like this, I cannot include a 0. So the domain of this function is 1/2 infinity because 0 in the denominator is not acceptable. Is that okay?
Yeah, I just needed to draw the result.
It's really much easier than we think, this domain situation. Good. Next question. Anything else?
Can we do number 14 on the homework we just
Yes,
did?
please. Yes, yes. Can you give it to me? I don't have it.
Yeah. F of x equals x cubed minus 5 over x.
Everything over x?
Just the 5.
Just the 5. That's okay.
Yeah.
Okay. What am I doing with this?
The second derivative.
Very good. Awesome. Perfect. So f of x equals x to the third minus 5 times x to negative 1. I always try to make our life much easier if we can. So the first derivative is 3x squared plus 5x to negative 2. And the second derivative is 6x minus 10x to negative 3. And that's all we need. Is this okay?
Yes.
Perfect. Anything else?
Can we also do 12 on the homework?
Yes, please.
It was y equals and then parentheses x plus 5 to the 7th, and then parentheses 4x minus 1 to the 10th.
Yes. So this is similar to that long problem that we had last time. So the first derivative, I'm assuming. Perfect. Bring down 7. Subtract 1 from the power times the inner function prime. It's 1. Times 4x minus 1 to the 10th plus the first function times the second one prime, 10, times 4x minus 1 to the 9th times the inner function prime, which is 4. So now I'll rearrange it a little bit. So I have 7, x plus 5 to the 6th, 4x minus 1 to the 10th, plus 40, x plus 5 to the 7th, and 4x minus 1 to the 9th. I see that both factors are in common. They have to be removed with the smallest possible power, the smallest of the two. Power 6, power 7, it has to be 6. Power 10, power 9, it has to be 9. Out, 7 is still in, and one of these is still in. Now I'm here with plus 40. This, 6 of them are out, so 1 is still in, and all these 9 are out. So now I have to combine here. Don't change anything in the front. You cannot. X plus 5 to the 6th, 4x minus 1 to the 9th. Now, 28 plus 40, 68x, negative 7 plus, this is 200. So it's plus 193. Let me do this one more time just to make sure. 28x, 40x, 68x, negative 7 plus 200. 200 minus 7, 193.